Hello and welcome to a video on equilateral triangles. Equilateral triangles are kind of like to rectangles or quadrilaterals. They're the squares. They're like the perfect triangles. All the sides are the same and all the angles are the same. So it turns out that if all the sides are the same, in other words, if all three sides have the same length, then it follows that all three angles will have the same measure as well. Now this is even more important for these because we know that all triangles have 180 degrees. So if all the angles are the same, then they must all be 1/3 of 180. So all of the angles in an equilateral triangle are always 60 degrees. 60, 60, and 60. All right? So we can say here that if the three angles are equal, then the three sides are equal. So in this triangle, if the three angles are equal, then it's also true that the length of AB is equal to the length of BC is equal to the length of AC. And there's no special number for lengths, unlike angles. Angles has that special 180, so there's going to be 60s involved here. When we say that the three sides of a triangle are equal, then it follows from that the measure of angle A will equal the measure of angle B will equal the measure of angle C, and that will always be 60 degrees when we're talking about angles. Always be the same number. Okay, so here's an example. Let's look at this first triangle ABC where we're given a side length of 9. Now, if these two are 60, by the way, you don't have to be told this is an equilateral triangle. You know why? You have enough information there already. You already know these two are 60. So we can do our old thing that we've been doing, and we can look and say, well, if we have 60 plus 60 is 120, subtract that from 180, and we get 60, then we know that these three angles are all the same. And we know from what we know about isosceles triangles that the sides across from equal angles are also equal. So that means all three of these are 9. They're all 9 feet. So that's pretty cool. All you need to know is the two angles, and that's it. You know that if they're both 60, then they're all 60. And it's therefore equiangular and therefore also equilateral. All right, so here we can say angle C is 60 degrees, and the length of BC is 9 feet, and the length of AC is 9 feet. All right, let's look at another one. In number 12, we're not told anything about the angles, but we know that it's equilateral because all of the sides are marked equal to each other. So all of the sides are 24. We're not asked that, but they are. That's what these marks mean, right? 24. But more importantly, in this case, it's therefore equilateral. And so we're kind of going to go by this sentence right here and say if all the sides are the same, all the angles are the same, and they're all 60. So all of these angles, 60, 60, and 60. All 60 degrees. All right, let's look at this last one. So here, we're given a triangle, and this time we're told it's equilateral. And so that means all three sides are the same, but that also means all three angles equal 60 degrees. So let's just take care of that angle first, because that's the one that usually say, look, well, I don't know what that is. All I know is one angle. No, you know exactly what that angle equals. It's not a right angle, but it's kind of the same amount of information. You already know the number. So this is 7x minus 3 equals not 90. I'm thinking right angles. It's 60. All right, let's add 3 to both sides. And so we know 7x equals 63. Let's divide both sides by 7. And so we know that x equals 9. Now let's find y. Now the sides are named by y. We can set any two of these equal. So sometimes students don't like when there's a choice. And I'm sorry, but this time you're going to have to make a choice. Yeah, you get to choose which two of the sides you're going to set equal in your equation. You don't need all three sides. If it's equilateral, you can choose any two. So I'm going to look at these numbers, and I'm going to pick the ones with the smallest numbers. So I'm going to choose 9y plus 1, that's a y, not a 4, is equal to 11y minus 23. Purely only because it's got the smallest numbers. It really doesn't matter other than that. Subtract 9y from both sides. Add 23 to both sides. And my real equation is 24 equals 2y. Divide both sides by 2. And my conclusion is y equals 12. All right, I hope you found this helpful.